Okay, let's talk about some arithmetic sequences. Arithmetic sequences are just patterns that have common differences. The common difference we call D, and what it is the consistent difference between each number. For example, if we have 1, 4, 7, 10, 13, and we are looking at that, and we are saying, okay, the question is, what do we do from 1 to get the next? Well, from 1 to 4, we're going to add 3. 4 to 7, we add 3, add 3. So the common difference then is going to be we are adding 3. So D, our common difference, is 3. Now here in this example, we've got from 5 to 3, we're going to subtract 2. 3 to 1, we subtract 2. Subtract 2, subtract 2. So if we're going to subtract 2, then our common difference is going to be negative 2. And yes, arithmetic sequences are linear functions. Now there are two common formulas for arithmetic sequences. One is the recursive, and that is actually very simple because what recursive says is it's recurring. It means all we're going to do every time is add the same number or subtract the same number from the previous term. So we have a term, we look at the previous term, and we're going to add 3 every single time, or we're going to subtract 2 every single time. This, the t sub n minus 1, is what we use to show the value of the previous term. So if our previous term is 2 and our common difference is 3, our next term will be 5. And then we take our 5, that's now our previous term, we're going to add 2 again, and our next term will be 7. So that's the way that works. You just keep adding or subtracting the same time. Notice that n is the number of term. If we're looking for the 5th term, we want the 4th term plus the common difference. If we are looking for the 12th term, we want the 11th term plus the common difference. Now, our explicit formula is what we can use to find a number that's not in order. We don't need the previous term for this one. We need our first term, we need our common difference, and we need whatever the term is that we're looking for. So if it's the 5th term, that is what our n is, and we will plug that 5 right in here. If it's our 12th term, then n is 12, and we plug that 12 right in here for the n. There is also another formula that we will use a little bit later that's just like this one, where we don't need the first term. It's whatever term we are given, and we will have an example of that next. Hold on. Here we go. So basically, what we have here is, if you're just going to find general terms, we're going to use the explicit formula, and here's the one. If you know the first term, this is what you use. So if we're going to find the 5th term, that means that n is going to equal 5. And if we know our first term is 3 and our common difference is 4, then that's all we need to know. All we have to do is plug everything right in here. Our first term is 3, goes in where t sub 1 is. We're looking for our 5th term, so n is 5, so 5 goes where n is. And our common difference is 4, so that is what d is. Then all we do is regular algebra and make sure that we follow the order of operations. We cannot add first. We have to we'll subtract this, then multiply. 5 minus 1 is 4 times 4 is 16, plus 3 is 19. So the 5th term in this sequence is 19. Now, what if we don't have the first term? Well, then we can substitute for 1, we can put an x in there. And if we are looking for the 5th term of a sequence where we know the 12th term is 125 and the common difference is 4, all we have to do is plug that in. We know that this is t sub 12. T sub 12 is 125. So we plug 125 in. We put our common difference in. We have the 5th term, but we know what the 12th term is. So here for n minus x, we are going to say that it is going to be 5 minus 12, which gives us a negative 7. So now we have negative 28. 125 minus 28 is 97. So we know that our 5th term in this sequence is 97. And if we keep adding 4 to it, our 12th term will be 125. Let's try some problems here. So let's say we need to find the recursive and explicit formula for an arithmetic sequence whose first term is negative 5 and whose common difference is 2.5. Okay, all we have to do, remember, we are not finding a term. We are just putting them in the formula. So if I have t sub n equals t sub n minus 1, do we know what our previous term is? No. Do we know what term we're looking for? No, we're not looking for a term. But we do have a common difference. It's 2.5, and it's positive, so we're adding it. So we say plus 2.5. This is the answer that we're looking for. Now, the explicit, it's a little bit more complicated because we're still not looking for a term, so it's still going to be t sub n. Do we know our first term? Yes, we do. It's -5, so we can plug in -5 plus, do we know what our common difference is? Yes, we do. It is 2.5 times n minus 1. Do we know what our n is? No, we don't, because we're not looking for a term, but we know it's still going to be subtracted. So basically, all we have to do is say this. T sub n equals -5. We have to do the distributive property plus 2.5n minus, what's 2.5 times 1 is 2.5. But we're not done yet, my friends. We have to combine our like terms. -5 minus 2.5 is -7.5 plus 2.5n. That is what we're looking for. Let's try another one, different. Let's say we need to find the fifth term of the sequence defined by the formula where we know that t sub 1 is -4, and we are given the recursive formula. So that means, what do we need? We're going to use the explicit formula because we're going to find a specific term. We need the fifth term, so we are finding t sub 5 equals t sub 1 -4 plus, we need a d. Well, if we look at our recursive formula, it tells us that our d is going to be 3. So we do 3 times n minus 1. Yeah, we know what our n is. It's our fifth term. So we have 5 minus 1. Now, I know that t sub 5 equals -4. I'm going to use my distributive property. Ooh, no, I'm not going to use my distributive property. I'm going to make it easier. I'm going to say 5 minus 1 is 4 times 3 is 12. So my fifth term is 12 minus 4, which is 8. Done. Yes, you can do distributive property up here, but I don't do it unless I have to do it because it makes a little bit more work. Moving on. Find the seventh term of the sequence whose common difference is -2 and first term is 6. Be sure you can try these on your own. All you have to do is make sure that you pause the video and try it first yourself. You might want to do that now. Find the seventh term of the sequence whose common difference is -2 and first term is 6. Okay, we're looking for t sub 7 equals, our first term is 6 plus, our common difference is -2. Therefore, it's not letting me erase. I'm going to rewrite it then. T sub 7, hold everything. T sub 7 equals 6 minus 2 times, what is my n? It is a 7 minus 1. So t sub 7 equals, I cannot subtract first, 7 minus 1 is 6. 6 times 2, it's going to be 6 minus 12, which is -6. My seventh term is -6. Moving on. Now find the first term of the sequence whose common difference is 1/2 and 15th term is 28. Notice this time we need to find the first term. We're still going to use the same formula though. We know that our 15th term is 28, so I'm going to write it a couple of ways. First, I'm going to say I know the 15th term. Now, I'm looking for the first term. My common difference is 1/2. I know that my n is 15 because we have t sub 15, so it's going to be 15 minus 1. Still looking for my first term, but I can't have two variables here that I don't know. But they've given me that the first term, or the 15th term, is 28. So all I need to do is plug that in. T sub 1 plus 1/2. 15 minus 1 is 14. Now, I know that 14 times 1/2 is going to be 7. T sub 1 plus 7 equals 28. I subtract 7. T sub 1 equals 28 minus 7, which is 21. So the first term in this sequence is 21. Okay, so the next thing we need to talk about is what is an arithmetic mean. An arithmetic mean are the numbers that are in between each of these terms. And how many, for example, there are 4 arithmetic means between 10 and negative 30. 1, 2, 3, 4. So if you look at it, you would want to ask yourself, what do you have here? Well, how do I find these? I need to know what the common difference is because I need to know what I'm going to add or subtract to each one. Well, how many common differences are there? Well, there's one from here to here, and one from here to here, from here to here, here to here, and here to here. So I've added it 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 5. You will notice that there are 4 arithmetic means in between these two numbers, and there are 5 common differences. So from 10 to get to negative 30, I have to add 5 common differences. Now this is really simple because it's very basic algebra. All I have to do is solve for d. I will subtract 20, so I have 5d equals negative 30 minus 10, which is negative 40. And then I'm going to divide by 5 each time. So my common difference is negative 8. That's how we find the common difference. We have to use the arithmetic means. So now let's look at this problem. And it's find the third term of the sequence whose 12th term is 4 and whose 16th term is 16. Well, you'll notice that we don't have a first term. We don't know what that is. But we still need our common difference. So the first thing that we are going to do is find that. We are going to say, if we know our 12th term, so that's going to be t sub 12, 13, 14, 15, and we know our 16th term, t sub 16. So our 12th term is 4. Our 16th term happens to be 16. How many common differences are in between those? 1, 2, 3, 4. 3 spaces, 4 common differences. So from 4 plus 4d, I will get 16. This is very convenient. I'm going to subtract 4. So I have 4d equals 12. So that my common difference is 3. Very nice. Now, I'm still looking for the third term of the sequence whose 12th term is 4 and whose 16th term is 16. I can pick either one of these to use. I'm going to pick the 12th term. So mine will be t sub 3 equals t sub 12 plus my common difference times n minus x. Now you need to remember that your n here is your 3 and your x here is your 12. So we're going to go backwards. So we're going to end up having a smaller number because we have t sub 12. So that means that it's okay for this to happen, for us to have an n minus x where it's going to be 3 minus 12. So now again, our third term is, we don't know. Our 12th term is 4. Our common difference is 3 plus 3. Now we have 3 minus 12. So we end up with our third term going to be 3 minus 12 is negative 9 times 3. So we have 4 minus 9 times 3 is 27. It's a negative though. So for minus 27, or 27 minus 4 is 23, but it's going to be negative 23. Our